In this lesson, we're going to look at how you find the inverse of a quadratic and a square root, and we're going to see how those inverses relate to each other. I'm going to start by looking at the parent function of a quadratic, which I've graphed here. You can see a parabola. I also graphed some key points, and then I'm going to create a table of those values over here on the left. So whenever x is -3 squared is 9. When it's -2 squared is 4, and so forth. So there's a table and the parent function. What I would like to do is find the inverse of y equals x squared. And if you remember the rules for finding inverses, you find inverses of graphs by simply switching the x and y values. So I created another table, did this one in green, and you notice what I did is I put the y values from the blue table in the x column for the green table, and then I put the x values from the blue table in the y column of the green table. And then I'm going to graph those points, and I did that graph in green. So right here you can see my green graph, my points, and then I'm just going to connect those with a line. And that is my inverse for y equals x squared. Now what happens is, when we do an inverse, we would like for it to be a function too. If you remember your function rules, if I draw a vertical line through this like so, you notice that it touches the green graph in two places. That means that the green graph did not create a function, and so we really can't call this some function. But what we do most of the time is we just take off the bottom part of that, the negative part, and then we can call this the square root function, which in this case is y equals the square root of x. And so that is the parent function for y equals square root of x. So we usually use this as a function, and we just draw it like that. You'll notice that if I draw the y equals x line, then inverses are supposed to reflect across the y equals x line, and you'll notice that this one does. The right half of the quadratic parent reflects across the x line and makes the green graph that I have right now, which is the function, or the parent function, y equals square root of x. Now, like all functions, if we want to find the inverse algebraically, we can do that by switching the x and the y and solving for the new y, just as we do with linear functions. So let's try one of those. This is a quadratic function, y equals 3x squared minus 6, and I'd like to find its inverse. So in order to do that, I switch x and y, so I'm going to write x where y is, y where x is. Everything else stays the same. And now I'm going to solve for my new y. And I do that, I move the 6 over to the left side, it becomes positive. I still have 3y squared left on the right. To get rid of the 3 in front of y squared, I divide both sides by 3. Remember, this is assumed to be a 1. And so that becomes 1/3 x plus 6, no, plus 2 when I divide it out, and that's equal to y squared. Now, I'm not quite finished yet because I still have y squared and I would like for it to just be y. Rules of algebra say that the opposite of squared is to take the square root, which is what I'm doing right here. And when I do that, I'm left with just y on the right side, and I have square root of 1/3 x plus 2 on the left side. And that is my inverse. If you want to write that in function notation, you use the -1 right here to show inverse, and then you say the f inverse of x is equal to, draw my square root here, 1/3 x plus 2, all under the square root sign. And that is the square root of, that is the inverse of 3x squared minus 6. Let's do one more of these. This one is also quadratic. We know that because it has square. It has a square in it. That is its degree of 2. So we want to find the inverse, so we're going to do it exactly the same way. We're going to switch our x and y. Rewrite the problem like that. Now we're going to solve for y. Starts basically the same. Add 3, and we're left with y plus 5. This time the 5 is in the parentheses with y, so we can't do anything more until we take the square root of both sides, which I'm going to do right now. Taking the square root of y plus 5 squared just leaves y plus 5. And on this side I have x plus 3. And I take the square root of that. Now I still have a 5 over with y, that's not a big deal. I'm just going to move that 5 over here with x plus 3. Now it becomes minus 5 and equals y. So I have found the inverse of that one. F inverse of x is equal to the square root of x plus 3, and then outside of the square root, minus 5. Now, if the quadratic and the square root are inverses of each other, that means that if I take the equation that I just got for the inverse, and then I find its inverse, then I should get the equation that I started with. So I'm going to go up here and I'm going to do that. I'm going to take y equals the square root of x plus 3 minus 5, and I'm going to find its inverse and see if I get the equation that I started with when I started the square roots, or when I started the inverse. So I'm going to switch them. So I'm switching x and y, and I'm going to solve for y. I'm going to move the 5 over and add it to the x. And now I'm going to square both sides. So when I square that side, notice that I said both sides, so I have to square all of that. And there's x plus 5 squared equal to y plus 3. I could go ahead and multiply out the polynomials x plus 5 squared, but I don't need to do that because I can see that I'm going in the right direction here. I'm just going to move the 3 over and subtract it. It's equal to y. And if I just turn the whole equation around, y is equal to x plus 5 squared minus 3, which is exactly the equation I started with when I took the inverse of the quadratic. So taking the inverse of a quadratic will get the square root function. Taking the inverse of the square root function will get us back to the quadratic equation. Works just like taking inverses of any other function. You switch the x and y and then solve it for the new y, and you will have the inverse. If you would like to see other lessons on other topics, I invite you to go to my website at mymatheducation.com. You'll find other topics there. Or you can simply use the YouTube channel, My Math Education, and I invite you to subscribe to that if you'd like to see other lessons. I'd be glad to have you. Thanks for watching this one. Hope to see you again.